Hi everyone and welcome back. I just wanted to separate this video because it's a different topic and it's a little shorter. This could have been done anywhere really after we covered derivatives, but essentially what we're doing is connecting an f of x graph to its derivative. So the slopes play a big part here. So the slope of the original gives me the height or the y values of the derivative. So we want to figure out how to do a rough sketch. So really the last 2 points are the important ones. Max and min on your original graph, your f of x graph, will produce x-intercepts on your derivative. Increasing slopes on your original graph will mean your derivative is above the x-axis, and decreasing slopes on your original graph means your derivative is below the x-axis. So when you're looking at this f of x graph, the easiest way or the quickest way I get through these is to do a sign diagram of the slopes. So where does the slope change? Slope usually changes or always changes at a max or min. And at a max or min, the slope is 0. Right? So this x value is 0. The slopes are decreasing. We get to this min, the slopes are increasing. So that means in my derivative, everything before 0 is below the x-axis, and everything after 0 is above the x-axis, which means 0 has to be an x-intercept, and we also know that because it's a minimum. So again, not too picky over the exact slant of this line. However, if this is a quadratic and we take the derivative of it, we know we're going to get a linear. So we always lose 1 degree. And that's kind of the basic type question. That's the lowest degree I can really give you is 2, because then we go down to 1. We could take the derivative of a linear and get a horizontal line, and that would be considered a special case. But this is an example where you've got the decreasing, increasing, and a min. Let's look at another one. This one is cubic, so over here I'm going to get a quadratic. If I do my slope or my derivative sign diagram, I base it on maxes and mins. So I got a max here at 1, I got a min here at 3, and I just kind of look at what the slopes are doing. So slope is increasing, then decreasing, then increasing. Now I just go to my other graph that I want to sketch. So at 1, I know I've got an intercept because the slope is 0. At 3, I've got an intercept because the slope is 0. Before 1, I'm positive. So it's going to be quadratic. So essentially, I don't know where the min is, and that's a very rough sketch. I don't know where the min is, but I don't care in this case. It's just a rough sketch. So I got positive, positive, negative. And that's how you do a cubic to a quadratic. Couple more. Quartic. So this one's going to be a cubic. Again, sign diagram for the slope, and we got 0 slope here at -1. We got a max there, so another 0 slope at 0, and another 0 slope there at 1. So again, be careful. Even though this is above the x-axis, it's decreasing. So negative, then we're increasing, positive, negative, positive. So -1, 0, and 1 are my x-intercepts in my derivative sketch. Negative means I'm below. So this is a cubic. So I can kind of guess how it's going to go if I know where to start. It's got to go up through there, below, positive, then negative again. And the turns, we don't care about where you turn. You can make it as exaggerated or as close to the axis. Essentially what's supposed to happen is, let's say the slope here is -3, then you should have a dot at -3. But we don't know that. We're not calculating the slopes exactly. Alright, so that's those two. The last one is a V-graph, so this is a special case. We talked about V-graphs in an earlier section. This point is not differentiable. So if I'm doing the derivative value and this is linear. So this slope is down 1 over 1. So I know that the slope here is -1. And then this is in the opposite direction, up 1 over 1. So I know the slope over here is 1. So it's not actually just decreasing or increase. I know the actual value in this case. Here, because it's a V graph, it's undefined. So how would you graph that? Well, at 0, we're undefined. After 0, we're +1. So we need the empty circle there. And we got that. Then on the other side, we've got an empty circle here. And we've got that. So that's what the derivative sketch of a V graph would look like. So that one's a little different, but it's a good question for a special case. All right, so that's the end of this unit. If you have any questions, just post them in the comments or email me. And I'll be back next week with some more notes and videos. Bye for now.